Hi everyone. So today we're going to work on solving radical equations. Now, it's about where's the variable and how can we isolate it when it's underneath a radical. Okay, so that's what we're looking for and what techniques can we use to solve. All right, so we're hopefully going to be able to solve radical equations when we're all said and done, and be able to solve radical equations with two different radicals. That's going to be the hard one. All right, so let's first define what a radical equation is. A radical equation is an equation in which the variable appears in the radicand, meaning underneath the radical. So something like the fourth root of, let's say, 2x minus 1 is equal to 5. Or shall we say a minus 2 underneath the square root is equal to 7. Or something like 4 minus the square root of 3x plus 1 is equal to, that's 1 under square root of 6 minus x. Yeah, that's pretty intense. But notice that where the location of the variable is. They're all underneath the square root sign, and that's what we're looking for. So how do we solve for x if it's underneath whatever root? Square root, fourth root, fifth root, maybe to the 1/3 power. Okay? So we use this process called principle of powers. So it basically is the idea that keeping the equation balanced, that we can take both sides to a power. So you know how we can multiply both sides of an equation by the same thing and it doesn't change the fact that they're equal to each other? That's what this is, except instead of multiplying, we're raising to a power. For example, okay, if I do 2 plus 1, we know that's equal to 3. And we're going to be allowed to go, okay, I'm going to square both sides. Okay? So if I square both sides, that's going to be 2 plus 1, or 3 squared, is equal to 9. And then we get 9 equals 9. Okay, so we're allowed to raise both sides of a quantity, or both sides of an equation, and raise it to a power, and that doesn't change the fact that the equation is still balanced. So that's what we mean by principle of powers. And this is the concept that we're going to use to solve radical equations. All right, so let's take a look at how this is going to work. All right, so first thing we're going to need to do is, we can, but it's not very pleasant to solve the way it is right here in this problem. Notice that we have a radical, the x is underneath, and we have minus 3, and then we're going to equal to 4. So it's going to be in our best interest to isolate the radical. So let's add 3 to both sides. Okay, now that the radical is by itself, we can get rid of the radical. So how do we get rid of a square root? Well, we're going to square both sides. Okay, because they cancel each other out. Squaring a square root eliminates. It's like dividing undoes division, addition undoes subtraction, that kind of thing. So we're going to get x equals 49. Now, here's the thing, you should always check your answers, whether it be in your head or writing it out. So square root of 49 minus 3, I want to know, does that equal 4? That's 49. Square root of 49 is 7. So is 7 minus 3 equal to 4? Yes, it is. We're good to go. That's our answer. Always check your answers. All right, let's try this one. Okay, so we have x plus 5 is equal to 3. So the first thing I'm going to do is subtract the 5. So we get negative 2. Then we're going to square both sides to get rid of the radical. So we get x is equal to 4, right? Negative 2 squared is 4. So now I'm going to check my answer. Always check your answers. So square root of 4 plus 5 is equal to 3. I don't think that's true. 2 plus 5, that's 7. That definitely does not equal 3. So this particular problem has no solution. 4 is a solution to x equals 4, okay, when we squared both sides, that's called an extraneous solution. It's not a solution to the original problem. And the reason why it doesn't work in this particular case is that I don't have a square root equal to a negative number. It just doesn't happen. Unless there's a negative sign in front, then that's different. But if we're talking about the principal root, the positive square root can't equal to a negative number. And that's why that one doesn't work. All right, so why don't you pause the video and try numbers 1 and 4, or 2 and 4 and see how you do. All right, so here's 2. So add 3 to both sides, square both sides, solve for x, and I got 24. Then go back and check and see if you're right. So 24 plus 1 is 25. Square root of 25 is 5. 5 minus 3 is 2. We're good to go. So 24 is the solution to that problem. But in number 4, once again, we see that we have a square root equal to a negative. And again, we may not remember that. And that's okay, because if we do our check, we're going to end up seeing that 11 does not equal 1. Therefore, our solution of 25 is not correct. There's no solution. So here's some steps that we've been doing, but we didn't write. Isolate the radical term on one side of the equation. Use the principle of powers and solve. And then always check your solution in the original equation. That's really important, that we go back and always check into the original. All right, so let's try some more. All right, so here we have x equals the square root of x plus 7 plus 5. So again, we're going to isolate our radical. I'm going to subtract the 5. Okay, we're going to square both sides because it's a square root. If I was cube root, I'd cube both sides. But here's the problem. This is now x minus 5 quantity squared. That, keep in mind, people, that is not x squared plus 25. This is what we have to do. We have to write it twice. Remember? So we're going to get x squared minus 10x plus 25. So please don't forget, if you're squaring a binomial, such as x minus 5, you do need to write it twice and multiply, FOIL, split distribute box, whichever method you prefer. And then on the other side, we get x plus 7. And since we have a quadratic, we do have to set it equal to 0. So I'm going to subtract the x. That's going to make this a negative 11. I'm going to subtract the 7. And that's going to make this 18 is equal to 0. So I now need factors of 18. Yeah, we're going to have to factor. So we just multiplied. Now we have to factor? Yes. All right, so I need factors of negative 18 that add up to negative, or positive 18 that adds up to negative 11. And that is negative 9 and negative 2. Okay, we're going to set both equal to 0. Yeah, all that stuff is coming back into play. So we're going to get 9 and 2. Does that mean you have to check both answers in the original problem to see if they both work? And the answer is yes. Okay, so I'm going to come back up to the here. I'm going to do my check. Okay, so I'm going to go 9 equals the square root of 9 plus 7 plus 5. So 9 equals the square root of 16 plus 5. 9 equals 4 plus 5. Okay, this looks good. Okay, so it looks like 9 is a good solution. Okay, now just because 9 works doesn't necessarily mean 2 does not. It depends on the nature of the problem. So now I'm going to check 2. Oops, that's plus 5. All right, so I get 2 equals the square root of 9 plus 5. 2 equals 3. I don't think this is looking good. 8. Nope. Okay, that's not true. So that means 2 is not a solution. So our only solution here is 9. And that happens sometimes. So you could get multiple solutions. You can get one solution. You can get no solution. It just depends on the nature of the problem. All right, so this one's a little different because notice there's no radical, but we have that fractional exponent that we talked about earlier. Now remember, that just means the cube root of 2x plus 1. Now how are we going to get rid of this fractional exponent is the same process that we would with a radical, which means I'm going to take it to the power. So what undoes 1/3? 3. So I'm going to take, before I even do that, I got a little ahead myself here. 1/3. I'm going to subtract equals -5. Now, we don't have to worry about negative with a cube, because remember, you can take the cube root of a negative number. An answer, a negative can be an answer. So I'm going to take everything to the 3rd power. Okay, so these are going to cancel each other out, right? 3, if I multiply straight across, that becomes 3/3 or 1. So they cancel. So left with 2x plus 1 is equal to -125. Solve for x. So I'm going to subtract the 1. It's -126. Divide by 2. -63. Okay, so I'm going to come back up here and put -63 in for x. So again, always do your check. So we get 2 times -63 plus 1 to the 1/3 power plus 5. The question is my answer equal to 0? So this is going to be -126 plus 1 to the 1/3. So that's -125 plus to the 1/3 is equal to 5, plus 5 equals 0. This is -5. So we do get 0 equals 0. And ta-da! We are good to go. So -63 is our solution. Okay. Why don't you try, again, these are going to take a little bit longer, 2 and 4. Okay. All right, so there's our solutions. Okay, I found 6 did not work, but 15 did. And I know this seems weird, but 37/3 does work. So that's our solution for x. All right, so now we're going to try a challenge question. And it happens to do if we have radicals on both sides of the equal sign. Okay, so in other words, I have a radical on one side, I have a radical on another, there's other stuff there, and I can't isolate one because there's 2 of them. All right, so what you're going to want to do is you're going to isolate one of the radicals, solve, and then you're going to end up with another radical, which means you're going to have to do this process all over again. So it's like a 2-for deal. You have to do it twice to finally get what the variable is equal to. Okay, so first of all, these equations might look something like square root of x equals the square root of x plus 1 minus 3. Something like that. Okay, you have variables, radicals on both sides. All right, so we're going to isolate one of the radical terms, use our principles of power. If the radical remains, perform it again, solve, and then check your possible solution in the resulting equation. In other words, always check your answers. All right, so this might take a little bit of brain power and energy here, so be prepared. But you guys got this. We can do this. All right, so one of our variable radicals is already by itself, and that's the 2x minus 5. So that's the one I'm going to solve for first. Okay, so I'm going to take it, I'm going to square it. Okay, so on the right, that's the easy part. There we go, radical cancel this out. Now, the problem, once again, is that that is a binomial, which means, I'm going to write this out, we have to write it twice and multiply, and that's going to get a little hairy. So, FOIL, 1 times 1, 1. 1 times the square root of x minus 3 is square root of x minus 3. Okay, square root of x times 1, so plus square root of x minus 3 plus. Okay, now you have the square root of x minus 3 times the square root of x minus 3. Multiply what's underneath. I'm not going to multiply that out, but there's 2 of them, so squared. Okay, so I have 1 plus 2 square roots of x minus 3. This guy here, okay, when you square a square root of square, isn't that just what's underneath? So, yeah, we still have this 2x minus 5 here. Okay, so we isolated the variable or radical that we wanted to get rid of, which was the square root of 2x minus 5. We took care of that. Problem. We still have a radical right there. So now we got to do this whole process all over again, which means I want to isolate the square root of x minus 3, which means I'm going to subtract Negative 3 and 1 is negative 2, which means I'm going to add 2, so that's going to make me minus 3 over here. And then I'm going to subtract the x, so x minus 3. That gives me 2 square roots of x minus 3. Now, I don't know about you, but I don't want to deal with a fraction, especially if I have to multiply it twice. Okay, so I'm going to leave the 2 where it is. I'm really not a fan of that, but we're going to. So when I square both sides, on the left, we're going to get x squared minus 6x plus 9. And again, where did I get that? X minus 3 times x minus 3. Okay? And then over here on the right, I'm going to square the 2, so that gives me 4. And then squaring the square root, x minus 3. Now you're probably going, well, why didn't you have to write it twice? Because there's no plus sign in between the 2 and the square root of x minus 3. So I can just square the 2 and square the square root. If there was a plus or a minus sign in between, that's a binomial. Okay, we would have to write it twice. Okay, so distribute the 4. Yeah, there is a lot of algebra happening here, and I'm sure your brains are really going to be hurting. 4 times 3 is not 13. Okay, set it equal to 0. Okay, so now we're going to have to factor. Factors of 21 that add up to negative 10 are negative 7 and negative 3. Okay. I'm running out of room. Okay, so we're going to get x minus 7 equals 0, so that's 7. X minus 3 equals 0, and that's 3. Okay, so I am going to tell you, okay, I just want to make sure I say this right before I lose this. Nope. Why am I doing the wrong problem? That's the wrong problem. I'm sorry. Oh, great. Yeah. Let's see. 14 minus 7 is 9. 3. 7 minus 3 is... Okay, 7 works. I'm doing that in my head. 6 minus 5 is 1. 3 minus 3 squared root of 0 is 1. Yep, they both work. Okay, so I just did that real quick in my head. We don't have to check those. Try 2. It's really long and complicated. We're not going to do number 3 here because that's even... All right. I'm going to be absolutely thrilled if we're going to be able to do this first part. The second part, those are challenge questions. I might put it as a bonus when we have our test. Have a great rest of your day, guys. Let me know if you have any questions, and I will talk to you again real soon.